ACL has lots of application, and one of it is NAT translation. And I also have a question for you. Do you deploy the NAT on your network or not? If yes, please write down 1. If no, please write down 2. Do you deploy the NAT on your network? Nobody used NAT before? I think this one should be very useful if you have some edge router on this edge is not our devices type. This is network type devices. If you want to use the devices to visit the internet, and these devices usually we will deploy the NAT, the network address translation. And why we use the NAT? Because in our network, lots of places we use the IP address is IPv4 address, but the length of IPv4 only 32. So now the IP address is not enough. And the traditional technology, we will divide the IP address to become private and public. And the private IP address can be used at the same time in different network. And if they want to visit the same resources like the internet, we have to translate the public IP address to become private network address. To translate the private to become public. And this technology we call is NAT. To solve the problem that the IPv4 address is not enough. And another solution is we can deploy the IPv6 address in our network. But this solution is a little difficult. That's because not only your terminal support IPv6 is enough, all the devices in your network and all the server you want to visit to get the application, all of them must to deploy IPv6 technology. Then we can use the IPv6 to indicate IPv4. Because in our network, we have lots of network devices, so this working is very big. Maybe in some scenario, we will use IPv4 and IPv6 together, and in the future, to use IPv6 indicate IPv4 instead of IPv4. And this course, we will talk about 4 types of NAT: static, dynamic, overload, and the server map. And different scenario. And I guess lots of scenario in our network used is the overload NAT and the server port mapping. We will usually deploy in our network. But about the static and the dynamic, we only maybe faster talk about the principle. First, why we use the NAT? Because we have the problem that IPv4 is already not enough for us to use. So we can divide the network to become private address and public address. And the private IP address can be multiple use for different scenario, and the address can be same. So some scenarios, IP address is more can be used than 32 bits long. And the function, because the private IP address can be used at the same time, even the IP address is same. That's why if we want to visit the same resources like the internet, we have to do the translation to translate the private network address to become public address. Otherwise, there is address conflict. So this technology we call is NAT. And which part information should be translated? This is because why we have 4 type of NAT technologies. In the NAT, we have lots of concepts. One is inside local address, usually in the private network, and the terminal gets a private IP address, and this address we call it inside local address. And another is internal global address, external network address of the internal, want to visit the outside. That means we will translate an IP address to public. And this IP address we call is internal global address. And when we visit the outside to visit the internet, and the destination IP address should be a public IP address. And this one we call is outside address. We will have a global and the local. Usually global and your local will be same. If like this topology, we want to visit the traffic from left to right. And also we will record the relationship. We will add the record, which IP address is being translated now. And this one we call is translation entry. And we have simple one and extended one. Simple one means we only translate the IP address information, but extended we also have to translate the port information. So like this example, the inside source IP want to visit the outside 101.1. The message sent to be the router. The router will do the translation to change the inside local to become the outside local. And the inside global is the IP address you want to visit the destination to continue keep the outside global. So this is the IP address. And we will translate the source information. And the public and private IP address, we say the private IP address any organization can use at the same time. And the private address cannot be visited on internet. Like the company A and B, all of them can be used for the private. So we have to know which IP address should become the private IP address. These three segments. You also can use it on your network. It doesn't matter. But if you want to visit the internet, you have to apply the public IP address maybe for your career network from the ISP. And then you can do the technology address translation and to make the private to become public. And about the NAT classification, depends on which part information should be translated. We can divide it as a NAT to become static NAT. And inside the IP address to be translated and outside the IP address. We only translate the source IP information, but it's one by one. And another one is dynamic NAT. Static NAT means this public I will apply for PC1 and the other one cannot use. But dynamic means we have two public. The first one I translate for PC1. If PC1 use finished, I will allocate for another devices. So this is a dynamic. So we will have an address pool. And the third one also is the most useful one is overload NAT. We not only translate the source IP address, but also translate the port number. Because dynamic also one public IP address can be used for one private IP address at the same time. So if you have 100 IP address, 100 computer want to visit the internet at the same time, you cannot get 100 public IP address, right? But one IP address, we can have more than 60,000 port number. We can use one port number to indicate one private IP address. This technology we call is overload NAT. And the last one for port mapping. The upper three NAT usually used to let the internal visitors want to visit the internet. But some scenario, maybe your server will be deployed in your internal network, like your FTP, your HTTP have the private IP address. But some public user also want to visit your company page. So in this scenario, your server also have to provide a public IP address for them to visit. So this technology we call is port mapping. And later we can see the detail one by one, what's the process, what's the configuration. The static NAT we call will achieve the one-to-one mapping for private of the public address. So this one also can solve the problem that the PC1 want to visit the internet resources like the topology of the PC4, but this is a fixed public IP address. So in this scenario, if PC1 want to visit PC4, let's say the process 1, 2, 3 step, PC1 send out the message. Source IP is PC1, destination IP is PC4, and then the message sent to route 1. Because we already add the static NAT on the route 1, and the inside local 192.168.1.1 is connected with 100.1.1.100. So the message will be translated of the source IP to become 100.1.100 to visit the PC4. And later, when come back from PC4 to the route 1, when route 1 receive it, I will find my destination already exists on the translate table. And finally, the IP address will be translated again, come back to send to the PC1. So this is a whole process. So if we use a static NAT way, we also can let the private address to visit the public network. But the disadvantage is this public IP address only can be used for PC1. So we cannot solve the problem that the address is not enough, right? The configuration is you have to create your interface, which interface is inside, which interface is outside, and then to add the connection of the source and the destination. IPNet inside source static 192.168.1.1 to 100.1.1.100. So if I receive the message from gigabit 01 and the source IP address is 192.168.1.1, this IP address is wrong. Sorry, this is the IP address of the router. If I receive the message, the source IP address is 192.168.101, I will translate to become this IP address. Okay, so this is static. And you also can use the ping to test the connection. And another one is dynamic. We say static only can let one public address for one private address. And the IP address also is it's not enough. So dynamic means we will create an address pool. In the pool, maybe you have multiple address, for example, 2 or 3. And we will re-enter the address for the private. So when the IP address in the IP address pool is mapped, and then we can get the IP address when we use. But if we use successfully, this IP address can arrange for the other guys. So let's see the process. If PC1, 2, 3 want to visit the PC4, the process is now we have the pool of the route 1 from 100.1.100 to 105. And if PC1 want to visit with each other, the source IP address is PC1, destination IP address is PC4, then the message sent to route 1. And then route 1 will take the public IP address and record on the table, and the inside local address is 192.168.1.0. And then the message will be sent out to PC4. When PC4 reply, I will directly take the tape entry and to translate the destination IP address again and forward to the PC1. At the same time, if PC2 want to visit each other, also we will send out the message and enter about the route 1. Now we will find the second public IP address 102 to give the PC2 because 101 now is used for PC1. And then send the message out. PC4 will give a reply, match the entry, we will send the message to PC2 again. So if we have a pool at the same time, 5 PC can be used to visit the internet. But if the 6th one want to visit the internet, they have to wait someone free to use this IP address. So this is a dynamic NAT. And the configuration, first one, you also have to decide which interface is inside, which interface is outside. The different one is you have to create the address pool. And in the address pool, you have to add the public IP address NAT, and the pool IP address NAT pool name is 瑞杰 100.101.100. This is the start IP address. This is the end IP address. And there is a NAT mask. And this is the address pool. And the second one, you have to select which IP address should be passed through and use this IP address. So you have to use the ACL to define the range. ACL at least 10, and the permit, and this is the range. And the key command is ipnet inside source list 10 and use a port range. So this is a dynamic NAT. After we do the configuration, PC1 and PC2 also can at the same time to visit the destination. But if the 6 ones cannot, because our address pool is not enough. And we can use the command show IPNet translation to find that this address already be translated for the private, right? And the same port number, but different inside local and inside global. So this is a dynamic. But in the more scenario, we hope that one public IP address or maybe two public IP address can be used for multiple terminals or multiple applications. So in this scenario, we will also translate the port information, and the technology we call is overload. And the configuration is very similar like the dynamic NAT. We want to multiple private IP address can be mapped to one public address. So in this scenario, for example, PC1 and PC2 want to visit the PC4, but we only have 100.1.1.100 this public IP address. And how to indicate different private IP address? We can use the port number to distinguish them. And on the Regia RGOS platform, dynamic NAT is enabled with overload function by default. So you can directly use this function. And the process is very similar like the dynamic. Now PC1 want to visit each other, and the source and the destination. Of course, when you use the dynamic way, we also will add the port number. But here we will translate it, so we write down on the table. And we will use the public IP address 101.100.3000 to indicate the PC1, and finally to visit the internet. And then we will come back to translate again to visit the PC1. But at the same time, if PC2 want to visit each other, and here is the source, destination, and then we will take the same public IP address, 100.1.100, and the different one is we will use 3001 to indicate the PC2. So finally, the message will be sent out like this, and come back to PC3, to PC2. And theoretically, we can support more than 65532, lots of terminals, and one public IP address we can directly to visit in the internet. So this is the overload NAT. And the configuration is similar like a dynamic, but only one difference is overload. We have to add the IPNet inside source and list 10. This is the range of the private IP address. And which IP address we can use of the public? You can directly to take the public interface. You also can use the public IP address and then the overload. And when you use the ping to test, you also can find the ping successfully. And we use the show IP net translation. We can find the ICMP and the different inside global. We will use the same public IP address but different port number to indicate different private IP address. So this is a translation. And this scenario is the most useful scenario. And which port number will be used? The router will select automatically. We don't care about this part, but you have to add the command is overload. And the next one is the server port mapping. And this also will be used in the special scenario. For example, in your company, you have lots of server like HTTP, FTP, Telnet server, and OA server. And about this server may be located on your firewall zone and gets the private IP address. But maybe your employees or some users want to visit this server. They cannot directly to enter the private IP address. They cannot visit successfully. So about this server, we also have to provide one public IP address for the user to visit each other. So in this scenario, the dynamic and overload net or static only will be used for some intranet user to visit the external network. If we use a static net, also one server, we need one public IP address. The public IP address is not enough. So in this scenario, we will use a server port mapping. Like this one, we will use one public IP address, 101.1.100, and the port number 8 to indicate HTTP server, 21 to indicate FTP, 23 to indicate Telnet. But all of them will use the same public IP address. Of course, they will have different private IP address. And the key command is here. You also have to decide which one is inside, which one is outside. The difference is IPNet inside source static. This key configuration is similar like the static net. And we have to choose which protocol use. Those 4 applications, all of them will be encapsulated into the TCP. So the protocol we will choose TCP. The inside address is 1234 and the inside port number. This port number should be same with your server port number. And the public IP address is same. And the public port number, you also can use same port number to indicate this information. So after we add this configuration, when we want to telnet one server, we can directly use the public IP address and the public port number. And finally, the router will translate to become the private information, and then we can visit the destination. So this is the server port mapping. And you can telnet and the public address, right? And then you will direct it to log in the devices. And you use the command show IP net translation, you can find lots of information. And here also is the question we can test on the net. Which of the following statements about net are correct? Can you show me some answer? The answer should be A, B, C, and D. All of them are correct. Static net are not suitable for internet user to access the internet, right? That's because the public IP address is not enough for us to translate one by one. So all of them are correct. So about this topic, we will talk a lot of technology of the net, right? When our network address is not enough, and one solution you can deploy IPv6 technology. But IPv6 technology also is a little complex. If you are interested about IPv6, please contact your region postal seer. We will update a new ISE enterprise, and in the enterprise we will have one presentation for IPv6. And another technology we will talk about is the NAT to translate the private IP address to become public IP address. And the key point we will use in our network is the overload NAT. About the overload node, we can use one public IP address and provide multiple service for the private, and one port, one public, one private information. So this is a summary. So about this training, do you have any questions we can discuss together? Because next week, same time, we have 3 days of the wireless technology. And lots of technologies we will discuss together within these 2 weeks. Do you have any questions? This afternoon, the topic is a little heavy and my speed is a little faster. After this training, we will upload all the video on the YouTube and send the video to your email. If you register on the email successfully, we can get your email address and we will send the record video to you. So it doesn't matter, maybe in the future you will have the chance to deploy these technologies.